Welcome back, everybody. We are now ready to put all the pieces together, and we are ready to add rational expressions that do not have the same denominators. Now, in our previous modules, we learned how to add and subtract fractions that did have the same denominator. And our rule was real simple. Adding fractions easy as can be, all you need is an LCD. Write the bottom, collect the top, reduce the fraction, now you stop. That's what we sang when the denominators were the same. Now today, seeing the denominators are not going to be the same, we added a little extra phrase in our song. So our song goes, adding fractions easy as can be, all you need is an LCD. That's still the beginning step. To add and subtract fractions, rational expressions, you must make sure those denominators are the same. Here comes the new part. If you change the denominator, you must change the numerator. So guys, if you know those denominators are not the same, if that denominator is a 2 and that denominator is a 3 and they're not the same, we're going to have to change them by making the LCD. And when we change that denominator, we'll have to change the numerator. Then we can write the bottom, collect the top, reduce the fraction, then we'll stop. So we have one extra step. Okay, let's look at our PowerPoint. I want to put together this rational expression. 3 over 4a minus 2 over 3a plus 1 over 6a. So I see 3 fractions, and I'm asking you to add and subtract. Right now, we cannot do that. To add and subtract, our denominators must be the same. We have to have like terms. So we're going to need a common denominator, an LCD, for 4a, 3a, and 6a. So again, if you can't look at those denominators and figure out the LCD in your head, the rule is that always works is factor every denominator as low as it can go into primes. So if you take 4a, that would be 4 would be 2 times a. If you take the denominator 3a, well, that's already prime. 3 is prime, a is prime. If you take the denominator 6a, 6 is 2 times 3 times a. Once you get your denominators all in lowest terms and primes, you take the most of every prime term. So let's look at the numbers. I'm looking at 2. 4a has 2 2's, 3a has no 2's, 6a has 1 2. How many 2's do we need? That's right, we need the most, 2 2's. I see the number 3. 4a has no 3's, 3a has 1 3, 6a has 1 3. Well, 3a and 6a have the same amount, so we just need to take 1 3. Then we look at the variables. 4a has 1a, 3a has 1a, 6a has 1a. They all have the same amount, so we just take 1a. So altogether, our common denominator is going to be 2 times 2 times 3 times a, which is 12a. Now, if you could have figured that out without doing the factor trees, that's great. But a lot of us need that tree to see the prime pieces. So now what we're about to do is, now that we know we're going to make a new denominator, we're going to have to create 3 new fractions that are equivalent. So the first thing I'm going to do is write my fractions all with denominators of 12a. And I'm going to look, how do I make that first denominator of 4a become a 12a? Well, I would multiply to 4a the number 3 to make 12a. So if I multiply the denominator by 3, I'll multiply the numerator by 3, and that is why 3 over 4a becomes 9 over 12a. The next denominator, the original was a 3a, and I'm making the new one become a 12a. What do you multiply to 3a to make 12a? You multiply by 4. So now I'll take my numerator 2 and multiply it by 4, and that's where I'll get my equivalent fraction 8 over 12a. My last fraction, my old denominator is 6a, my new denominator is 12a. What do I multiply to 6a to make a 12a? I multiply by 2. So take your numerator 1 and multiply it by 2, and you get a 2. So now that new equivalent fraction is 2 over 12a. So now that I have my 3 new equivalent fractions, I rewrite this expression. It will now be 9 over 12a minus 8 over 12a plus 2 over 12a. Everybody agree? Now I can add and subtract because I have all the same denominator. But let's fix something. We've talked about this. In algebra, there is really no such thing as subtraction. You add the opposite. So do you see where it says 9 over 12a minus 8 over 12a? Change that subtraction symbol to addition and make that 8 the opposite. And that's why that 8 becomes negative 8. So now we have 9 over 12a plus negative 8 over 12a plus 2 over 12a. Now we can just write the bottom, 12a, and collect the numerator. 9 plus negative 8 is 1. 1 plus 2 is 3. So now we have the fraction 3 over 12a. But remember that fraction bar means division, and 3 and 12 could both be divided by the greatest common factor, 3. So 3 divided by 3 is 1, and 12a divided by 3 is 4a. And that expression becomes 1 over 4a. So I followed my song. Adding fractions easy as can be, all you need is an LCD. I found my LCD, 12a. If you change the denominator, you must change the numerators. I did that. Every fraction got a new denominator of 12a, so every fraction got a new numerator. Then I wrote the bottom 12a, I collected the numerators, and then I reduced. That's all there is to it. It's the same rules of arithmetic, only now we're doing it with algebra. Okay, let's go to the whiteboard and try some.